going to jump into calculus basics. There is your question on the screen. Without further ado, let's jump straight into it. Hello, Kamo. Hello. I know. I run away every now and then, but I'm back. I'm back.
'Kay, we good, right, Teacher Cocker?
I'm all good.
Okay, cool. Off my pimp. Let's see if we can put it in the bag. Let's see.
I think they'll be able to. They're quite a sharp bunch. Last time I remember, they were a pretty sharp bunch. I think we should do this very quickly at that. It shouldn't take us too long. You guys are really good at this. I'm going to give you guys 2 more minutes and then we're going to start with the question. Inani is asking, let me see, 9.1 is the answer 4x. No, there's a constant missing at the end. Okay, so normally what we do, especially when they ask for first principles, remember they don't really want the answer. Okay, but we still do need to get the derivative. So by the time we get to the end, you want to make sure that you can derive this very quickly just to make sure that you end up with the correct answer at the end. So you can just go f prime x is going to give us 4x, but this one over here should be -3, right? So I know you guys can differentiate. That's easy. It's the steps that I want to see you guys taking. Okay, so first principles is not about the answer. It's about the process. So make sure that we're doing that correctly. Okay, so check again for me, Inani, what happened to your -3 there? Make sure that it's still there as part of your answer, all right? Yes, sir. Somebody just asked me, ma'am, will we lose marks if we forget the limit as h approaches 0? Yes, we will. Because the whole point of first principles is to show the limit as it approaches from either side. Okay. So they're very, very strict about it. They're very pedantic about it. So make sure that you're not forgetting. No worries, Inanda. Inani, sorry. Okay. Somebody named iPhone is saying 9.1 is 4x plus 3. Please check your answer again. Also, please give us your name, so we're not calling you we're not calling you iPhone. Lesejo, not exactly. Okay, so the answer we're looking for is 0.03. Okay, that's about time, so we're going to get started on this question. Okay, the answer we're looking for is 4x minus 3. Where did I get 0.03 from? Okay, 4x minus 3. But the point of this exercise is not to differentiate. It's to use first principles. Okay, so first thing we're always going to do is we're going to rewrite our functions up here. F of x is equal to 2x squared minus 3x. And then what I'm going to do up here is I'm also going to put up here f of x plus h. Before I start my question, just to make sure that I don't forget anything, then wherever I see an x, I'm going to replace it with x plus h. So I'm going to get 2 open brackets x plus h all squared minus 3 open brackets x plus h. And then I'm not going to leave that there. I'm actually going to FOIL it out and get the answer that I want before we continue, right? So I'm going to put there 2. This is going to give me x squared plus 2xh plus h squared minus 3x plus 3h. And that's going to give me 2x squared plus 4xh plus h squared minus 3x plus 3h. And yes, part of my screen is covered. I'm sorry, I completely forgot to remove the thing. Okay. Lesedi, does that help? Are we okay there? Okay, cool. All right. So I know wherever in my first principles, wherever I see my f of x plus h, I'm going to replace it with this long doohickey over here. Wherever I see f of x, I'm going to replace it with this. Now, remember, guys, this is not an exercise in finding the derivative. No. It's in the way we express the derivative. So we're going to write here, f prime x is equal to the limit as h approaches 0 of f of, yes, it's 2h squared. Thank you, Linda. I missed that. I was testing you, you passed. Well done. Okay, you passed. F of x plus h minus f of x all over h. Okay, then we're just going to continue. Remember, we do not leave the limit behind until we get to the very final answer. So we're going to take it with us all the way, right? The limit of as h approaches 0. Now my f of x is that long thing, so I'm going to replace it here. 2x squared plus 4xh plus 2h squared minus 3x, because that is now minus 3x plus 3h minus, And then I'm going to take this part over here and I'm going to put it in brackets because that minus is going to turn that negative 3x into a positive 3x. Okay, so I'm going to have 2x squared minus 3x in here. All of this over h, right? Things need to cancel out. Do not forget your limit. It must come with you. I'm going to get 2x squared plus 4xh plus 2h squared minus 3x plus 3h minus 2x squared plus 3x all over h. My 2x squared and my 3x are going to cancel. So 2x squared minus 2x squared will cancel. Negative 3x plus 3x will cancel. And then what I will have left, my limit as h approaches 0 of 4xh plus 2h squared plus 3h all over h. Ma'am, doesn't it become 2x plus h all squared? Yes, Marilyn, I'm going to explain what I've done in just a second. I'll explain again. Okay, this is the limit as h approaches 0. I'm going to take h out as a highest common factor on the top. So I'm going to then have h out, and I'm going to have 4x plus 2h plus 3. What did I do here? Why is it plus 3? Teacher Yules, what did I do? Okay. I left here. All right. So over there, when I distributed that in, this should have been a minus 3h. This should have been minus 3h there, because we should not get plus 3h. So I think we all made the same mistake. Okay. So this should be minus 3h and not plus 3h. Minus 3h over there. Over here as well. Minus 3h, and this over here should also be minus 3h. Linda says, can you do separate steps and then put it in the equation? Yes, you can. Yes, you can. You absolutely can, Linda. All right. So this then becomes minus 3, not plus 3, minus 3. Okay, all over h. Now, these two things are going to cancel. H and h will cancel. And I cannot drop the limit just yet. Not yet. Give us one last step as h approaches 0 of 4x plus 2h minus 3. Now, anything that is tending towards 0, if you multiply anything by whatever is tending towards 0, it's still going to give you 0. So this whole section over here is going to tend towards 0. And that's when I can drop the limit. I can then say this is equal to 4x minus 3. Okay. All right, give me a thumbs up in the chat if you manage to get an answer that looks similar to mine. Remember, I'm not interested in this answer here. Nobody's interested in that answer. What we want is this, these steps here, because we all know that you can differentiate. We are very, very aware that you guys can derive. That's perfectly fine. The thing that we want to do is the steps. We want the steps. All right. Okay. I'm about to show you now. I'm going to show you now, Masero. All right, so the first thing they're going to give you a mark for, whether you do it separately like I do, if you do it over there or you do it during this, right, they're going to give you a mark for substituting, right? That's the first mark that they're going to give you for substituting. Then they're going to give you a mark for simplifying, so that part over there. They then... Oh, no worries, Marilyn, that's perfectly fine. Okay, then they're going to give you a mark for, excuse me, the final part where we get over here, right before we take h out as a common factor. Okay, they're also going to give you a mark for taking h out as a common factor. That should give you 1, 2, 3, 4, and the fifth mark is going to be for the final answer, so for your 4x minus 3. All right. Masejo, I hope that answered your question. Okay, are we happy there? All right, let's get to the next question. All right, we're going to look at question 9.2, right? Before we do, I'm just going to, yes, Yes, Sihle is asking in 9.2.1, is that 4x to the power of 5? Yes, it is. Let me zoom in a little bit. Let me make it just a little bit bigger so we can all see the values that we're looking for there. All right. Okay, I hope that helped. Okay, now just remember, guys, your 9.2.2, whenever we differentiate anything, we do not want any radicals. So we do not want square roots of any kind. We do not want x in the denominator of anything. So no denominator of x, nothing like that. And we want no brackets. None of these things. So we need to remove all of those things except your square brackets because those are defined by d of x. Okay, but everything inside, we must remove all of those extra little doohickeys on the inside. All right. Okay, I'll give you guys 4 minutes because 9.2.1 should go by very fast. So this is the one that might take a bit of work. Half x to the power of 3. Negative a half x 3 minus 2 over 9 x to the power of, not negative 3, not negative 3, Linda, check that last, that negative 2 over 9 x to the power of, check that negative 3 there. Okay, yeah, but everything else you're spot on, but remember, you still have to differentiate. You still need to do that. Okay. Yes, there we go. Okay, correct, Linda. Well done. Give everybody else a few more minutes. Kamogelo, that is the correct answer for 9.2.1. Correctly, Humelo. Valentle, double check your 9.2.2 for me, please. Correct, Ovayo, well done. That's it. All right, okay, I'm going to call it there. Let's have a look quickly at the answers that we're going to get. Now, 9.2.1 is free giveaway marks. They've basically given these marks to you because we just need to use our differentiation over here. Now, please, guys, let's be as OCD about this as possible, okay? So when we write the answer, we're not going to leave out the important part because they're giving you a specific way to express the derivative. You must include dy dx in your answer. So your answer must start by saying dy dx is equal to. Okay, you must show us the difference between the function or the function of y and the derivative of the function. Okay, so you need to start with dy dx is equal to 20x to the power of 4 minus 24x to the power of 3 plus 3. And I'm sure none of us had a problem with this one. Okay, not y. not at all. Lesego, y is the function itself. What they want from you is dy dx, the derivative. Okay, so if you write y, what you're actually telling them is that my function is this. Okay, also over here, they want you to use that denotation. So you must use the denotation that they're giving you in order to differentiate. Okay, do not leave that behind. Right, so over here, first I'm going to clean this up. Now, before I take the derivative, I need to make sure that I'm leaving this thing within the brackets while I'm moving my radicals around, and I'm only going to let go of that d, the d to the x at the very end of my answer. I keep it until I'm ready to differentiate, and then I drop it. Only when I'm ready do I drop it. So everything that I'm about to maneuver around, I do that inside the square brackets. Okay, so first thing we're going to do is we're going to get rid of that cube root. We're going to make it x to the power of 1 over 3. So I'm going to have negative x to the power of 1 over 3 over 2 plus, I'm going to multiply the squared in first before we start. I'm going to get plus 1 over 9x squared, right? So I'm going to then continue. This is equal to d of x of negative x to the power of 1 over 3 over 2 plus. Now, the 9 is going to stay in the denominator, but my x squared is going to go up. It needs to be x to the minus 2 over 9. Now, I will not fault you if you've written this separately. So if you've written it as d of x as negative a half x to the power of 1 over 3 plus 1 over 9 x to the power of negative 2, you're allowed to do that as well. Okay, so if you've split the coefficient of x in each of those, you're more than happy to do that. Now that we are ready to differentiate, I'm going to drop the equation there, the d of x over there, and then I'm going to differentiate. I should get negative 1 over 6 x to the power of negative 2 over 3, okay, plus, oh, I'm lying, minus, ooh, why am I lying to the people? Minus 2 over 9 x to the power of negative 3. Now, in matric, in your final paper, they do not mind you leaving your exponents with negative exponents, especially when you're differentiating. Nobody's going to fault you for that. You won't lose a mark if you don't now take that negative 2 and take it to the bottom and bring it to the top. No, they don't care, as long as you've differentiated correctly. Okay, Sika says, is it good to leave 9.3.1 answer that way? Because when we come up with those big numbers and powers, I feel like I have done something wrong. And Sika, you have done absolutely nothing wrong. You've done the question 100% spot on. They do that sometimes to make you think that you've done something wrong. Have you ever had like that instance where you find the answer to a question and the answer to your question is 27 over 13, and then you feel like, something's not right. Why would I get such a weird looking number, right? They do that on purpose because they know that many of you are going to be like, no, it's not a nice round number like 5 or 2. If you've done the process correctly, okay. Okay, then you'll do that. All right, Shirufato, the information I'm giving you here is coming from Teacher Lee, who marks matric papers at the end of the year. Okay, so I'm pretty sure she knows what she's talking about, I hope. Okay, but if your teacher is pedantic about you leaving it with positive exponents, I'm happy to do that. Okay, we can go negative 1 over 6x to the power of 2 over 3 minus 2 over 9x cubed. If you wrote that, that's fine too. You're going to get your marks regardless. All right, let's look at the next question over here. I don't want us to do this one. I feel like it's the exact same question just again. Where's question 10? All right, let's do question 10, peeps. I'm just going to move over a little bit. Okay, I just want to make sure I'm not cutting anything off. Move this a little bit in. Okay, there we go. All right, I'm also, because the section is worth 15 marks, we're going to try our best to spend just around 10 minutes on it. Okay. All right, I don't really recommend us taking too long on these types of questions, but about 10 minutes should be okay. All right. Dx is basically just another way of saying dy dx. Okay, there are certain ways that you can write the derivative of x. So dy dx is one of the ways, d of x is one of the ways. Let me see, what else have I seen? I've seen f prime x is also a way to derive. There's another one that's just not coming to my mind at the moment, but there's different ways to show that you are deriving. Okay. And dx just happens to be one of them. There are quite a few. There's one I'm missing here. I think I remember from my university days, when we take the second derivative, we should write d squared y over dx squared, something along those lines. Yeah, or dy squared over d squared x. Can't remember. It was first year. It was a long time ago. Okay, but we also had a situation like that.
Yes, you need to put the dash. So yes.
Yes, sorry, I completely forgot. Yes, thank you, teacher Yolanda. We need to put the dash there, especially when we do the second derivative. Yes, true. Thank you. So is B negative 6A? No, it shouldn't be. It should just be 6. See, B should just be 6. Yeah. Amachalo, is that the coordinates of A? Let me see the coordinates of A. Yes, correct. Correct. Oh, I see. All right, Sifle, let me have a look. No, my sweetie, it should be 3A. Should be 3A. Yes, Linda, you're correct. Yes. Sihle, it should be 3A squared and 2BX. Okay. Let's have a look again. All right, 1 more minute, guys. It's okay if you're not done. We're just going to go through the questions either way, just for the sake of time. Lesego, can I ask you to finish that sentence properly, just so I know what you mean? Are you saying, must we use the turning points? Okay, well, I'm going to tell you now the turning points aren't exactly going to work in our favor, but let's talk about this. All right. So first thing we're always going to do, guys, before we delve into any question is read the information we've been given. So we're going to read this part of the equation first so that we know some things before we work into that. Saying, ma'am, yes, it does. Yes, it does. Okay, so we know that the graph of h of x is ax cubed plus bx squared. Okay, the graph has a turning points at the origin 0, 0, and at b, that is 4 and 32, a is an x-intercept of h. Now, we know that if the graph has a turning point at a point that is also an x-intercept, that tells us that this value of x is twice what the graph is. Okay, so if, let's say, for instance, we had a graph that went down, up, down like that, those 3 points, if we had those 3 intercepts, those would be the 3 intercepts that would make up our graph. Now, the problem with using the origin 0, 0 as an intercept that we can use is that if I multiply any x by 0, it's just going to give me a y of 0. So it's not exactly going to help me in any way. And I could use the idea that we have 4 and 32, but that's only going to help me so much. So as soon as I realize that they haven't given me enough information to solve for my first question, the first thing that should pop into my mind is that this should be a simultaneous equation. Okay, somewhere there needs to be a simultaneous equation. Now, there are 2 things we know for a fact. We know for a fact that at this point over here, that is a turning point. What is my derivative at that point exactly? What is the derivative of f of x or h of x here? What is the derivative of h going to be equal to? Anybody got an answer for me? Over here as well, the derivative of h of x must equal to, what are those 2 values that we should get? Any ideas? It should be 0, correct? Nolutando says 0, that's correct. So at that point, the derivative must be 0. And at this point over here, the derivative must also be equal to 0. Okay, so if we had the equation, we would get a squared number, we would factorize, and we would get 2 answers for x. One of them would be 0, and one of them would be whatever this value over here is. Right, so that's what we're going to do. We're going to derive, and we're going to look at both of those values at that point. Okay, so we're going to start with h of x. The derivative of h of x is going to give us 3ax squared plus 2bx, right? So to make equation 1, we are going to start by substituting, excuse me, we're going to start by substituting in the value 4 and 32. Okay, so we're going to substitute at that point 32. Just want to make sure I'm not lying to you guys. Okay, yes, I am lying. I'm 100% lying. Okay, don't listen to what I have to say. Okay, so at the point 4, the derivative is equal to 0 at this point. So we're going to take 3ax squared plus 2bx is equal to 0. And then at that point, we're going to use the fact that the x value at that point is 4. Okay, so we're going to substitute in here x as 4. So we'll have 3 times a, yes, correct, Pinga, that's it, times 4 squared plus 2 times b times 4 is equal to 0. If we clean this up, that is 16 times 3, that's going to give us 48a plus 8b is equal to 0. We're going to name that equation 1. Right, but we also know that if we don't take the derivative, if we just find the equation of the graph at that point, at the point there, then our x value corresponds to a y value of 32. So we're going to take the original graph, that one there, and we're just going to substitute in the y value and the x value that we know. So at h of x is equal to ax cubed plus bx squared. We're going to take h of x and replace it with 32. So 32 is equal to a multiplied by 4 cubed plus b multiplied by 4 squared. So 32 is equal to 16. Oh, it's not 16. I'm lying. It's 64. 64a plus 16b. And that is equation 2. I'm just going to write them out again down here. Okay, so the first equation that we got, we first took the derivative. We took the derivative of h of x, and we got 3ax squared plus 2bx, and we subbed in the point 4 and 0. We've subbed in the point 4 and 0 because at the derivative, my function is equal to 0, therefore my x value is 0. Don't we have to make a the subject of the formula? Yes, we will in just a second, Gerabetri. Okay, so I now know that if I put in the value for 3, right, I'm going to get 48a plus 8b is equal to 0, equation 1. Right, then I'm going to use my original. H of x is equal to ax cubed plus bx squared, and I'm going to sub in the point that I have on the graph, which is 4 and 32. Those are the 2 points I'm going to sub in. So I will have 32. I'm going to write it the other way. Okay, I'm just going to put the y value on the other side. So I'm going to have 64a plus 16b is equal to 32. And that is equation 2. Now, if I want to solve for these two simultaneous equations, I can choose which one I'm going to make the subject of the formula where. Okay. For me, it's not really going to make a difference. What I'm first going to do is I'm going to divide through in equation 1 by 8. So I'm going to divide here by 8, divide here by 8. Anything 0 divided by anything is just going to give us 0. Just want to make sure I'm not lying. There we go. All right. So we're going to have 6a plus b is equal to 0. And then instead of making a the subject of the formula here, I'm going to make b the subject of the formula. If you've made a the subject of the formula, you're more than welcome to do that. I'm going to make b the subject of the formula here. Okay, so in this equation, I'm going to get b is equal to negative 6a. That is my equation 3. Okay, and then I'm going to sub equation 3 into equation 2. Okay, and then I'm going to solve for b first. Okay, so I'm going to get, I'm going to solve for a first. So I'm going to get 64a plus 16 multiplied by negative 6a is equal to 32. Okay, I'm going to get 64a minus 16 times 6 minus 96a is equal to 32. 64 minus 96 is going to give us negative 32a is equal to 32. Therefore, a is equal to negative 1. Okay. All right. Okay, so that's the answer we get for A. And then I'm just going to go back into my formula and sub that value in. I'm going to go back into equation 3, sub in B is equal to negative 6 multiplied by negative 1, which is equal to 6. So there, I've managed to prove both of those points there. Okay, so there's definitely more than one way to do that. Sihle, I'm going to answer your question just now. Okay, so let's look at mark allocation here because it is worth 5 marks. First, they're going to give you a mark for your differentiating of that equation. Excuse me. Okay, and then they're going to give you a mark for using the point 4 and 0 to get your new equation. Ma'am, I would just like to ask, where do you make the coordinates 4 and 0 that you subbed in? Okay, I'm going to get to that just now, Simpiwe. Right, let me just do mark allocation very quickly. And then they're going to give you a mark for the equation that you get, that equation 1. Then they're going to give you a mark for equation 2 that you get from the original for subbing in 4 and 32 into the original. Then they're going to give you a mark for each of the answers that you get. Okay, right, 1, 2, 3. Let me just double check and make sure we're not lying. Okay, so they're only going to give you marks for the equations. Solving for the rest of it is grade 10 work. So then they're only going to give you a mark for that top part over there because the inevitable, if you do the method correctly over here, you should get to the answer. All right. Let's look at the beginning just for a tad bit again, because I can see some of you are a little bit confused. Somebody says here, can you please explain to me again, how do we see or must know that we are going to do a simultaneous equation? All right, Sihle, that's if they've given us enough information, but none of it is going to lead to some sort of equation we can use. Okay, like I was saying, if they gave us a graph that cut the x-axis, let's say, for instance, this was -2, that was 1, and that was 5. I automatically know that I can go h of x is equal to x plus 2, x minus 1, and x minus 5. Then I can solve for a. There's an a missing there. I can solve for a, and when I FOIL out, when I multiply out, I'm going to find my values for b and c. Now, they haven't done that. They've given us 2 points. Okay. They've given us 2 points. They've given us the point 0, 0 and 432. Now, I know that if a point is an x-intercept and it's a thing, and it's also a turning point, then both of those values for the graph should be 0. So I'll have y is equal to a, open brackets, x plus 0, and then x minus something. We don't know what that something at the x-intercept again is. X minus some value for a. We don't know what it is, right? So I don't have enough information to do that, right? The only information I do have at the moment is 1 point. I have 1 point. So I can automatically know that I'm going to take that 1 point that I have and sub it into my original. Now, when I sub this into my original, I'm going to get h of x is equal to, or I'm lying, not h of x. I'm going to get 32 because h of x is 32. 32 is equal to a multiplied by 4 cubed plus b multiplied by 4 squared. As soon as I see that neither a nor b is disappearing, none of them are disappearing, then somewhere there must be a simultaneous equation. Okay, if my a and my b do not disappear so that I can solve for one of them, simultaneous equation. All right. Lisel says, ma'am, where did you get the 3ax? All right. So if let's derive. Let's do the derivative of this thing. If we do the derivative of this thing, I'm going to get h prime x is equal to, that is going to give me 3a, and then I'm going to get x squared plus, I'm going to bring that 2 to the front, 2bx. Lisel, I hope that answered your question. Okay. Simpiwe says, ma'am, I would just like to ask, where do you get the coordinates of 4, 0 that we subbed in? All right. Simpiwe, if I take, all right, I don't know. I just want to ask you guys, please just put a yes in the chat if you've seen this before, right? We all know that if I derive or if I find the derivative of a cubic function, I'm going to get a parabolic function out. Are we aware of this? Give me a yes in the chat if you know this. Yes? Okay. So if you don't know this secret, if I take x cubed and I differentiate it, I'm going to get x squared out. And we know that x squared is a parabola. Okay, x squared is a parabola. Now, normally, if we're looking at our cubic function, the parabola has two turning, our cubic function has two turning points, right? It's going to have a turning point at 0, and it's going to have a turning point at 4. Now, when we draw the parabola, because our graph is negative, they've told us that a is -1. Our parabola is also going to be negative. So this is what's going to happen. My parabola is going to go through the turning point and also on this side through the turning point. So the turning point of my cubic graph is going to correspond with the x-intercepts of my parabola. So that point over there and that point over there are going to be the x-intercepts of my cubic graph. The turning points of my cubic graph are the x-intercepts of my parabola. Now, we already know the x value over here. The x value over here is 4 and 0. Okay. Do you see where I got that point from? Yeah. Am I making sense, Simpiwe? So if I want to then find a point that I'm going to use with the derivative, it's going to be the point 4, 0. All right. Okay, excellent. All right, I think we should continue. We spent quite a lot of time. Oh, let me plug my computer in before it dies. Okay. You're very welcome. No worries. Okay, let's look at 6. Oh, I'm saying 6. 10.2. Okay, 10.2 says calculate the coordinates of A. Can I just ask you guys to just pop a yes in the chat if we all know how to calculate for the coordinates of A? Do we all know how to do that? That should be quite simple. I don't think it's that difficult at all. Are we all okay with how to calculate that? Okay, good. So we're not going to spend too much time calculating for the coordinates of A because we have the cubic function. They've given us the cubic function. So we're just going to take the answer and we're going to sub in the x value we have. Sorry, no, the y value is 0, and then we can just solve for x. So we're going to get y is equal to negative x cubed plus 6x squared. And then we're just going to solve for x because our y value, that's our x-intercept, y will be 0. We're going to get x squared out, 0 is equal to x squared is going to come out, and we're going to have negative x plus 6. Therefore, x should be equal to 6. All right. Okay, so that shouldn't be difficult at all. All right, x is equal to 6, so my coordinates over here should be 6 and 0. All right, that's my coordinates for A. Write down the values for x write down the values of x for which h is increasing. All right, so we just need to go look for parts of my graph where my graph is increasing. Okay, which parts of this graph do we find that are increasing? Okay, I know that from there, from my turning point all the way to that part over there is increasing. Correct, so from the turning point, from the origin to the turning point. So my x values, my x will be in between 0 and 4 because they want the x values. Now, here's my question. Are they included or excluded? Are the points 0 and 4 included or excluded? What do we think? Okay. All right. I'm getting a few people saying included, somebody else saying excluded. Now, let's think about this. We all know that at the origin, my derivative is 0. So my gradient is actually flat, right? Horizontal line, increasing or decreasing? Horizontal line increasing or decreasing? It's neither. It's neither of those things. So we cannot include it because at that point, it is neither increasing or decreasing, same as on this side. So horizontal line, the derivative is going to be a horizontal line. We don't know whether it's increasing or decreasing. Remember, the gradient of a horizontal line is just 0. Therefore, there's no increasing or decreasing. So we must exclude. Do not include, guys. Exclude. Okay, if you use interval notation, right, if you use interval notation, you can say that x is an element of open brackets 0, semicolon 4, close brackets, round brackets on each side. Okay, so we must exclude because at the point itself, it is neither increasing nor decreasing. It's about to do one or the other. Okay, so we don't include that point. I know, so mind equals blown. All right, let's talk about concave down. Now, you can actually spot concave down on the graph, except we're going to need something very important. What do we need at the point of concave up or concave down? What do we need to find? Correct. The point of inflection or the second derivative. Correct. Okay, so we're going to have to derive twice in order to see where our point of inflection is over there. The part that's going to help us to find when it went from concave up to concave down. Right. So we'll take h of x or h prime of x, and we're going to derive that. Sorry, now I've forgotten where I've written my function. Where is it? Oh, there it is. Okay, h prime of x is going to give me negative 3x squared plus 12x. Take the derivative again. That's going to give me negative 6x plus 12. And then we're going to solve for x. We're going to make the derivative equal to 0. So negative 6x is equal to negative 12. Therefore, x is equal to 2. So my inflection point starts at 2. Over there, I don't know what the y value is. I'm not interested in the y value. They only want the x value. So I'm just going to say where x is greater than 2. I'm going to ask again, is 2 included or excluded? Is it included or excluded? Excluded, correct. We are excluding the point of inflection because at the point of inflection, it's neither concave up nor concave down. Yes, Pinga, exclude by default. Correct. Lesedi, how can I help, my sweetie? I see your hand is up. What's up?
Hi, ma'am.
Hello, my sweetie.
Ma'am, is it normal for us to do so much steps for the question that we just did now if it's only 2 marks?
The second derivative one.
Yes, ma'am.
Yes. Okay, because they're not going to give you special marks for second deriving. Okay, for deriving. At matric level, you should already know how to derive. Okay, and there's no other way that you're possibly going to find the point of inflection unless you do the second derivative. I don't even think we can find, like, let's say maybe a midpoint. Teacher Yules, it's not possible, hey? Because if this thing decides at this point to inflect a lot more, then we're not going to be able to that the midway point. I know when we look at it, between 0 and 4 is 2, yes, but because of the gradient of the graph or the shape of the graph itself, we don't exactly know what the cubic function is doing. So you must take the second derivative. But in grade 12, you should know how to take the second derivative of an easy function. There's nothing special there. All right. So yes, and if you want those 2 marks, you're going to derive. And we definitely want those 2 marks. So we're going to do the second derivative. All right, let's look at the next question. It says, for which values of k will negative x minus 1 cubed plus 6x minus 1 squared minus k equal 0? Now, this question is going to be a little tricky. right? Because we need to look at what they've done. What we normally do with this is I'm going to do this. I'm going to go h of x is equal to negative x cubed plus 6x squared. And then I'm going to rewrite this new one that they've given me right underneath it. I'm going to write negative x minus 1 plus, cubed plus 6x minus 1 squared. What's the difference between the two that they've just given me over here? This is the new function. I'm going to call it g of x. Okay, the difference over here minus k, the difference over here is that minus 1. Now, in any normal function, yes, correct, Pinga. In any normal function, if we added a value into that x function, it's going to shift my graph either left or right. And in this case, it's not going to be to the left, Pinga, because it's negative, it's going to move 1 unit to the right. We're going to move the whole thing to the right by one unit. Good. So our entire graph is going to up and shift 1 that way. That means my new turning point is now at 1 and 0. The turning point over here is at 1 and 0. Okay, everything is just going to move over 1. That turning point over there is going to be at 5 and 32. And that x-intercept over there is going to be at 7 and 0 and no longer at 6 and 0. Everything is just going to move 1 over. But that's not what they're interested in. What they're interested in is this negative k over here. Now they say, for which values of k will our k value have 1 negative and 2 distinct positive roots? Okay, let's think about what that means. Let's think about what that means. What they want from us actually is they want us to figure out which value is going to give us a new part of the graph that we can use to find 3 values, right? So they say to us here that we want 1 negative root and 2 distinct. Distinct means 2 different positive roots. So what they're actually saying is if we move our graph in this direction, we should get 1, 2, 3 new points. 2 of them will be positive, 1 of them will be negative. Now, the issue here is that we're going to get a new y-intercept. Okay, the issue here is if I move my graph that way, I'm going to get a new y-intercept. And I believe we're out of time, but I'm going to finish this question. Teacher Yules, do you mind if we just finish this question and then we can head off? Is that okay? I'm not sure if she's here. Okay, all right. So if we find the values for x, right? If we find the new y-intercept, excuse me, if we find the new y-intercept of this graph, we're going to make x equal to 0. Okay, we're going to make x equal to 0. So we can actually find a value for this new graph. Okay. Geez, hi ma'am, what if the turning points were not at the origin? Would we calculate 10.1 the same? No, we wouldn't. No, Lesepo. Okay, guys, I think this question, explaining this question is going to take quite a while because there are quite a few steps involved in getting to this question. Can we park this question and then we can start it up with Teacher Lee in the next lesson? But okay, the point I'm trying to make here is that we're going to make x equals 0 so we can find our new y-intercept. Okay, so we can find our new y-intercept in this new function. Okay. The answer is that x needs to be, or k needs to be in between 7 and 32. Okay, k needs to be in between 7 and 32. And getting to that, Linda, is going to be a bit tricky. Okay. Okay. If you would like to find this paper and go see how they've done the answer. Kamagelo, did you get the correct answer? Well done. If you'd like to see how they've done this question, this is the NSC 2021 paper. Okay. 2021 paper. Terofato, I'm not 100% sure there is. Okay, I don't see any other way for us to do that. Because if we want to find the x-intercepts, we need to find, or well, if we want to find where the graph needs to move in order for us to find that point, we're looking for the y value. Okay, so what k is going to do, let's look at it as any other graph. Do you agree? Let's say, for instance, if I had a parabola, if I had y is equal to x minus p all squared plus q, that last value over here is going to move my graph up and down. Okay, the one they gave you, Okay, and that will allow you to be able to solve for x. Okay, all right, so that last value is going to move my graph up or down. So this negative k over here is actually just asking us, how far up or down do you need to move your graph in order to get 3 different answers? But of those 3 different answers, 2 of them must be positive, 1 of them must be negative. And that's what they're actually asking for. Okay. All right, which is going to make it a little bit more difficult. Somebody named iPhone 2, you're going to make this new function that they've given you over here, you're going to make the x value 0. Once you get that answer for k, okay, you can take the k out, solve for this with x equal to 0, and whatever answer you get there, that's going to be your k value, because everything else will be 0. Okay. True. Pinga, it's not just you. Me too. Yes, 2021.